Regenerative braking. When a motor is operational, in other words, when the motor is rotating, we need to supply current and voltage in order for that rotation to be maintained. Once we remove the voltage and the current, then there's no more magnetic fields being generated in the motor except for the magnetic fields that are still there due to the hysteresis effect. Now, when we remove that voltage, momentum is keeping that motor rotating and it'll slow down over a period of time. But the moment I connect the stator of this motor to itself, then that residual magnetic field is going to generate a current, which in turn creates its own magnetic field, and that will actively decrease the speed of the rotation. Now, by connecting the stator to itself via a charging circuit, we can then use that momentum in order to charge a battery, for example. And then as that battery charges, when we need that power again, we can then just take the power from the battery and push it back into the motor in order to increase the frequency of rotation for that motor again. Now, where would we use variable speed drives? We would use them in devices where speed of rotation is very important. Stuff like fans, pumping systems, heating, ventilation and air conditioning systems all use some sort of variable speed drive system. When starting a motor, that motor will generate a lot of tension and stress within itself because it is immediately drawing maximum amount of current. By introducing a variable speed drive, we can now go and take that motor, and instead of having it run at full velocity from start up, we can increase the speed gradually over a period of time in order for us to save the motor from excessive strains. If you think of a pumping system, for example, that fills a tank, that pump, the moment the tank starts letting water out, we don't need that motor to run at full velocity from the get-go. That motor can start pumping water very slowly, and then as that tank empties, the speed at which that pump is operating can then increase in order to compensate for the losses in the tank. Start and run profiles. It is normal for the startup current in some motors to reach up to 6 times its normal running current due to the impedance that hasn't been generated yet, due to magnetic fields that needs the current in order to exist and the inductive reactances to actually come into effect. Like I said, that causes a lot of strain in the motor and on the load, and that is where soft starting comes into play, where we take the motor, we start it at low speeds, and then as the speed increases, we then, or as it becomes comfortable with a certain speed, we then increase the speed. Consider the star delta starter, for example. We start the motor in the star configuration, and then once it reaches the running speed, we then switch it over to the delta configuration. Now that same concept is applied with variable speed drives and the startup and run profiles of motors, where we start the motor, we allow it to obtain a certain speed, over a period of time, instead of expecting that motor to run at full operating speed immediately. Also in devices like elevators, for example, we don't want that elevator to go at maximum speed immediately. If you're in the elevator, it's going to be very uncomfortable as a passenger. So what we do is we let that motor start slowly and then increase its running speed to a comfortable speed over a period of time.